Aviation fuel is the lifeblood of any airport. A vital, highly flammable resource handled by Frankfurt's 300 highly trained specialists.
We have a very big responsibility doing this job because we always have to remember that the lives of all these people on board, they depend from the quality of our work.
Today, Georgios PORITSANOS is delivering the A1 kerosene to a departing A380. This too is a job where any mistakes could be catastrophic.
This is our ground cable, and we need to connect this ground cable with the aircraft.
Georgios must create an electrical connection between the ground, the aircraft, and his truck.
The reason for this is because during the refueling, both vehicles they build up electrostatic charge, and we need to dissipate this charge to the ground. It is very important.
If static electricity wasn't discharged into the ground, sparks could fly. And one tiny spark near all this fuel, and it could be good night Vienna, or rather, good night Frankfurt. To keep all risks to a minimum, the airport uses a secure underground network to transport the bulk of it. This is the Central European Pipeline. Originally built in the 1950s to supply military operations, this 5,300-kilometer network now pumps fuel from North Sea ports to civil destinations across Europe. Nowhere in Germany is more thirsty for aviation fuel than Frankfurt Airport. Every year, it uses 5 billion liters. That's 49% of all the jet fuel used in Germany. Once it reaches the airport, the fuel is housed here, in one of Europe's largest fuel stations. 10 huge tanks with a 180 million litre capacity. From the tanks, the fuel is then pumped around the airport through an underground hydrant system. The pressure in the hydrant is so great that one burst pipe could create a fountain of jet fuel reaching over 20 meters in height. If it was connected directly to the plane, this raw pressure would burst the fuel tanks. This is where Georgios's truck comes in. It provides the vital missing link between the hydrant and the plane.
This truck regulates the refueling pressure. We have a very high pressure that comes out of the hydrant.
The truck's hose connectors have special spring-loaded pistons. These continuously open and close the valve, which reduces pressure to a safe level. Georgios can transfer 4,000 liters a minute without bursting the plane's fuel tanks.
This would mean we would be able to simultaneously refuel 72 cars in 1 minute.
But before Georgios can start refueling, he has one final check to make. He has to make sure the fuel is clean.
There should be no foreign objects inside, like dirt, for example, and make sure that there is no water contamination.
Water is a common impurity in aviation fuel, and that can be a problem. In 2008, a Boeing 777 lost all engine power while landing at London Heathrow. The cause was trace amounts of water in the fuel. When the plane was at high altitude, the outside air temperatures had dropped to -56 degrees. Water in the fuel crystallized into ice. As the solid ice built up, it reduced the flow of fuel to the engines. Georgios's truck filters out any remaining water, and he can now refuel the A380. But it's not just a case of filling her up. Pilots determine the amount of fuel needed for each flight, and they only ask for what the journey needs. That means that a plane's fuel tanks are often only partially full. On some modern aircraft, the rest of the space is filled with a non-flammable gas, such as nitrogen. Using oxygen-rich air, would increase the risk of an onboard explosion. With a 12-hour flight ahead of her, this A380 needs a full tank of fuel.
To refuel a big aircraft like the A380 at your local gas station, this would probably take something like 2 weeks. But with this refueling pressure that we have here in the fuel flow, we are able to refuel an aircraft like this in about 30 to 40 minutes.
320,000 litres of fuel fill the wings, increasing the aircraft's weight by 270 tons.